Harcourt, who shouldn't need too much of an introduction, but I'll give him one anyway. He has been a regular speaker pretty much every year.
Every year, yeah.
Every year so far. So once we hit a nice round number like, I don't know, 5, we'll probably do a gift or something. So Andrew recently moved to become a principal consultant at ThoughtWorks. Apart from that, he's a few grams lighter because he's had a few things cut out of his back. So if he's moving around very stiffly, that's why. Don't pat him on the back and congratulate him on a good job afterwards.
Not a telepresence robot.
Telepresence robot. All right. I don't think he needs any more introduction. I'm going to pass over to Andrew Harcourt and really help me welcome.
Okay. Now, first things first. Can you hear me at the back? Yes? Thumbs up? So. Okay. This will be really funny because I get to adjust the volume and then clip this back on and I can't see what I'm clipping it to. How's that? One more? Okay. Do we have magic gadgets here? Mic master. How's that? Whoa. Let's not do that. I can totes do technology, me. Okay, how's that? Can people hear me now? Okay, wonderful. And I'll put this. So public service announcement, while addressing myself again, is if you live in Queensland, you should have your skin checked every year, which I did, which is why having these moles cut out was only a routine thing. But yes, you do want to have your skin checked. Besides, it's really funny when I do the robot dance in front of like a room full of people. Okay, hi. Thank you for coming. Welcome. Thank you for voting in these talks. I will apologize in advance. This is not the dinosaur talk. The dinosaur talk did get a bunch of votes, but this one was actually the one that was highest voted as far as I was concerned. So I'm kind of glad about that because it feels like it's the most important one. The dinosaur one would have been fun, but this one's actually going to be hopefully more valuable. But nonetheless, no dinosaurs. Firstly, thank you to our sponsors. Without them, today wouldn't happen. There will be a game of Spot the Sponsor partway through the talk. So if you spot the sponsor, put your hand up, shout out, and given that I can't lift my hands above my shoulders, Chris here, my lovely assistant, will be flinging a fantail in your general direction.
General direction.
General direction, yes. Okay, so the topic of this talk, simple, elegant, beautiful code. We're going back to basics. And why is that? Well, because we have all of these buzzwordy frameworks, and they're great for the most part. We have a whole bunch of buzzwordy techniques. If anybody's not yet achieved buzzword bingo on their card today, you've probably been playing it wrong. We've got all of this cool stuff. We've got all of these cool patterns and practices and frameworks and tools and stuff. And why are our software projects still going wrong? Well, yes. so try not to. So I guess we want to go back to the basics of, well, what are we actually trying to achieve? And as much as Agile has become a buzzword and even a byword and is very much passé now, the reality is that we're still actually quite bad at being Agile. We're quite good at being Agile right at the beginning of a project because, hey, it's easy and there's not much tech debt and there's not that much code, and how hard could it possibly be? Right? You can spin up a build in 5 minutes, and most people do. Everybody should. Most people do. Some still don't. But kicking it off is really, really simple. Right? Everybody can put together a backlog. That's easy, right? It's a wish list. And everybody can prioritize it from top to bottom. What happens 6, 12, 18 months, 2, 3 years down the track, though, is that this whiz-bang new Agile project isn't actually all that Agile anymore. We've started to have a whole bunch of quality issues creep in. And then, of course, the response to having quality issues creep in is, well, hey, we should have some more release management. We should have a governance process around releases. We should do all of these things, and that way madness lies. Come on, who's not been in that situation? Show of hands, who's not started a project thinking, we're going to do it, ow. Show of hands. I've fallen and I can't get up. Who has not started a project thinking, We're going to do it right this time. Right? Everyone has started that. Right? Everyone's had that thought, oh yeah, we've learned from the past, and by and large we do, right? But we've learned from the past, and that's really cool, and this time it's going to be great. And 12 months in, what are you thinking? Oh man, I cannot wait to get out of this project. I can't wait to have this thing done. I never want to see this again. How could it all go so horribly wrong? So agility is nice and it's wonderful, but it's not an end product in and of itself. Sustainability is a whole lot more important than just agility. Anybody can be agile for a short period of time. Sustainability means being agile for the long term. That means doing things in a way that doesn't preclude you from remaining agile. Yeah? And this last one on the list, I swear, people look at me like I've got a second head. When I walk into an organization and I say, hi guys, I'm here to teach you Agile. Who's happy? And people look at me like, what? What does that have to do with anything? You're here to teach us Scrum. You know, teach us like sprints and stories and stand-ups and ceremonies and wizard hats and stuff. Like, well, that's nice, but happiness is actually really, really important from an organizational perspective, from a cultural perspective, from a sustainability perspective, and back to, if you really care, an agility perspective. If your team is not happy, it's not going to stay the way it is. If your team is unhappy, life is only going to get worse. So what we need to care about is don't mess up the sandpit that we play in at least 8 hours per day. Okay? We want to keep things sustainable, neat, happy, so that we can continue waking up and doing what we like doing. Either that or we should like quit and go and live in a shack somewhere in a mountain. Who's heard someone say any one of these? All right. Who's never heard anybody say something like this? But we do stand-ups, of course we're agile. Who stands up in the morning and then looks at the requirement spec? Who's still got a requirement spec or a project manager or a heavyweight process, but they stand up in the morning? Show of hands. Okay, first fantail for you, sir. See? Purple shirt, purple stripy, black horizontal shirt. Here you go. And an excellent throw. All right. We do stand-ups. Of course we're agile. That's wonderful. Or the next one that you'll hear is something along the lines of, well, we've got our backlog and it's prioritized, so that's great. Now what we do is we chunk that into sprints. We call them iterations because we're not sprinting anymore. And then we get that signed off by the project manager, so we can say that in 12 months' time, we'll be doing this sprint with these stories in it. Give yourself a minty, sir. Right? Well, of course that's how it works. That's why consulting companies are still making money, because people still think that happens. Yes, and if it gets signed off by the board, then it's never going to change. Fire your board. Like seriously, if your board thinks that that's a good way to do it, either you're not communicating correctly to them, or your C-suite is not communicating directly to them, or they are and your board is incompetent, and that means your shareholders should revolt. But one way or another, that's just not a sustainable way, and everybody knows it. Right? Who's been told about the agile method? Right, the agile. Okay, too many hands went up to get fantails for that one. But yes, the agile method. At last count, there are like 190. Like there are more agile frameworks than there are countries in the planet that are recognized. So as soon as someone says we do the agile method, yeah, we've got a problem. Is that a thing still? You've got Microsoft Scrum 1.0, 1.1, 2.0. And yeah. Did you notice though that once you install the Scrum template, you can never change it? Cry. And yes, Scrum, if your company is writing Scrum in all caps, it's not an acronym, it's a backronym. Okay, we retrofitted a whole bunch of random words to let us Scrum. It's lowercase. Okay, agility is simple. It's the ability to respond rapidly to threat or opportunity. That's it. If you can't do that, you are not agile. End of discussion. If your competitor comes out with this scary new thing and you go, hey, wow, that's amazing, we can totally do that in 18 months' time. You are not agile. Right? Likewise, if a competitor comes out and you go, oh, wow, hey, they've got this really cool thing, and we've just discovered that they've done a press release saying, hey, you're going to be able to buy this next week. And we go, sweet, we can do 2/3 of that in 3 days and we can beat them to the punch. That's agile. If we can do that sustainably. That's all. Sustainability, because the professionals, for the most part, go home on time. I may be a bad example of that. Nonetheless, right, we want to go home on time. Why? Because we want to be able to keep doing what we do, and we want to be able to keep liking what we do. If we don't like what we do, why on earth are we continuing to do it? We should stop and go and live in a shack on a mountain. So go home on time. If you are thrashing yourselves, death march style for weeks, months on end, that's not good. We really, really don't want to be in that situation. So make that not happen. And happiness, as much as it should be self-evident. I mean, the right to the pursuit of happiness is enshrined within the US Constitution, for instance, right? We don't promise that you're allowed to be happy, but we promise that you're at least allowed to try for it. Now, a whole lot of people I talk with don't actually even acknowledge, don't even realize that that's a goal. You can actually set that for yourself, and then you can do things. You can put things on your task list that will do nothing but make you happy. But again, you want to be sustainably happy. So we want to think about how we do that. Be here to see code. Yeah? In a minute. Right. A couple of other points around sustainability and happiness, and I am going to harp on about that a little bit. But one of the things that kills a project is I can't leave because if I leave, no one else has got what's in my head. Right? That means 1, I'm stuck. 2, I'm miserable. 3, I've done a bad job. I should make it really, really easy for a new team member to get up to speed. I should make it really easy for a team to scale up effectively. That means that I should be able to rotate out of my project team and do other interesting stuff that keeps me interested in my work. If I can't do that, I've failed. So when we look at, we want to make our code beautiful, what does that actually mean? It means we want it to be simple. I want anybody who comes along to be able to look at my code, understand what it does and why it's there without asking me. If I get questions about my code, I've failed. Because that means that I've created a situation where the organization is no longer scalable and we can't bring new people into the team. I can't get out, no one else can get in, it's a real pain. Okay? Code is simple to understand. It's elegant and expressive. Okay? It doesn't just have to do the job. It has to do the job in a way that I can understand it really, really quickly so that I can look at a piece of code and go, you know what, this isn't even the class that I'm looking for, and close it again. Or ideally, not even have to open that class because it does what it says on the tin and that label's not what I'm after. Okay? The last thing, I guess, to keep in mind is beautiful code is never, ever finished. You are always going to find nicer ways to do things, and that's fine. Right? How long did it take Leonardo da Vinci to paint the Mona Lisa? Like, how many years was he working on it on and off?
2 sprints.
And he'll know that he's done when he sees it. All right. Now, you can't even read that code there, and that's my point. Right? I was going to say I'll throw a fantail too. I will have a minion throw a fantail to anybody who can actually tell me what this controller class is called. Customer, who got that? Well done, sir. Incoming. Thank you. Okay. 1, this is not beautiful code. It's a bad example. 2, tell me honestly, who's not written a class like this ever? Who's never ever written a class where it's a thing controller which does all of the things related to that thing? Right? We've got creates, we've got deletes, we've got updates, we've got searches, we've got state change to do this, that, the other. Right? And it's all in the thing controller because where else would it go? Yeah, good point. How many times do you reckon we should make Damien troll before he gets a fantail?
I'm kind of keen to see what else.
All right. So yeah, we can put it in page load if you really, really hate your life, but let's not do that. So let's have a quick game, because I'm going to make a bunch of assumptions about some things that people already do. If not, you should just do these things. Like the discussion's been had, the jury's back in, and we should just be doing this stuff. So no-brainers and spot the sponsors. If you're not using an IOC container, who does not know what an IOC container is? Anybody? Excellent. Who couldn't name me 5? Okay, cool. If you're not using an IOC container, use an IOC container. There's a video about that. There's an app for that. Actually, that one's not on Pluralsight. It's on YouTube, yeah. Use a message bus. Implement a message bus early. I've seen so many code bases who do the whole, hey, we're going to do the microservice thing, but service A is going to call service B, and then service B is going to Call service A to tell it to do a thing, which now means we've got cyclic dependencies and we're in a world of pain for nothing other than we didn't have an event broker. Right? Service A calls service B. Service B should announce that the thing was done and everybody moves on with their life. Okay? So bring in a message bus early. We should just do that. Log all the things. Sponsor, who got that? Who was up there? Good luck, Chris. Oh! Could one of the good citizens please make this happen? Okay, so log all the things. Now, this is really, really important. Logs are your friend. Centralized logs are your better friend. There is nothing more painful than having to shell onto a bunch of different boxes to have a look in the IIS logs directory just to have grep through a bunch of plain text to see what might have gone wrong, and you don't even know if you're in the right DMZ.
That's DevOps.
Okay, that's toast DevOps. All right, so we want centralized correlated logs. If you do not have these, go and get these. It is that simple. There's an app for that. Likewise, monitor all of the things. Actually, I should have put a plug-in for Not Dead Yet. But yeah, monitor all the things. So whether it's New Relic, Raygun, Pingdom, I don't care. But get something that's monitoring all your systems, make sure that it's doing its job so that you can forget about it. You should have, if it's a web app, for instance, you should have some kind of custom health check endpoint so that you can actually point your load balancer at /health check and make sure that it's okay. Not just that it's actually returning a 200 from your index page, which is probably cached, or it should be, but actually do a couple of quick health checks within the app itself. If it's not doing that, you should do that. Okay. Continuous delivery, I'm going to make the assumption that anybody here can take a revision from their Git repository, make a single change to it, and push that to production through all of the normal pipelines. If you can't do that, the professionals can. You should be able to say, whatever the revision is in production right now, get that, fix just that bug, and roll it through my normal environments, doing all my tests, and ship that. And you should be able to do that with nothing, there's no custom code, no custom scripting. You shouldn't be right-clicking and publishing from Visual Studio. You should be able to do this through your normal development and deployment pipelines. If you can't do that, it's worth it. Okay. Last thing, automation is your friend. Now, I know that I'm going out on a limb here, but who doesn't have a build? Does anybody not have a build? Does anybody not have a nightly build? I know people in this room don't have nightly builds because I've seen some of the projects. Right, so yes, every push, you want to build every branch, every push. You also want to build every branch every night because things change. Not just your code changes, but things that your code interact with change, and you want to know about it. You don't want to be waiting 13 months and then go, hey, we've got the CI build and it broke. Did anybody change these web services over there sometime within the last 1 point whatever years? Right, because that's a really awkward place to be in. So let's do that. And some quick anti-patterns before we actually start digging into code. So the first thing, don't automate awful. Okay, automation is your friend, but automating bad things is even more horrible because all you're doing is you're enshrining the awfulness forever. Okay, who's seen this one? Hey, I just read a JavaScript snippet to rerun all the failed pipelines. I know there are people in the room who saw this comment because I know which Slack team it came from. Okay, this is a thing. Don't do that. Or we had too many manual deployment processes, so hey, I wrote different batch files for each of them. We're deploying 17 different apps and we've got 17 different ways of doing it. Why would we do that? Okay? Have one, maybe two, but one. Don't just take the manual process, which is yuck, and automate it, because then you've enshrined that yuck forever. It's still not intuitive. Someone who comes along and wants to deploy product A and then wants to deploy product B, they're still completely different. Okay? So try to reach common ground in all of your apps before you actually start automating the stuff. Who's done repeat the UI tests until they pass? One brave person at least put up his hand. Don't tell incoming. So. But yeah, I get that UI automation tests are flaky, but really, fix the tests or fix the app. Don't just sticky tape up. If your DBA makes your schema changes, you're holding it wrong. I will say nothing more about that. Store procs. Who can test a store proc? Without a database. Oh, yeah. So who can do it in a unit test? Right? Who can do them in parallel? Right? Who can actually run a whole bunch of store procs under one unit test runner in parallel without doing funky in-memory databasey stuff? It's just not feasible. Why would you do that? In 1990s, when we needed to keep code close to data, like we needed to keep logic right next to the database because that was the only place that was fast enough to run it, when we're talking big iron and we've got like 4 cores and like 4 megabytes of RAM in our server, that's when stored procs were a thing. Okay. Now, stored procs are a stopgap. You put them in to do things like, hey, when this legacy app updates a table, we should like publish an event out of it and then do something else. But logic doesn't go there anymore. Let's not do that. Let them throw. If you can't handle it, let it throw. Move on. The last one, and this is a little bit counterintuitive, but this is starting to get into the whole, what about our actual code and expressiveness? Booleans are not your friend. The vast majority of times you use a Boolean, you actually didn't want one. Okay? That's because a couple of things. One, if I just say, hey, do foo, comma, false, what does that mean? What does false mean? What's true? Do I care? What's it going to do? Whereas even if I just have a 2-value enum, for instance, then that's going to be a lot more expressive. Hey, do foo, and it's like either foo should be done dot with a bar or dot without a bar. Oh, okay, cool. Well, that's expressive. I don't have to look into the code to see what it's doing. I can read what it says on the tin and go, yeah, I'm not interested in that. Okay. So give reasons. Use enums. Use like return collections of reasons why you can't do a thing or reasons why a thing failed. Don't just say, yeah, no. Hey, can I have a cookie? No. Or how about, hey, can I have a cookie? How many have you had? You've had 6 today. No, you can't have a cookie because you've had 6 today already. Okay? Explain why. It helps. In all seriousness, the number of people I've dealt with who are less mature than my 4-year-old, yes. So what are we actually trying to achieve? Well, we want to get inside the head of whoever comes next, because whoever comes next may well be me. And it may well be me after like getting woken up for a production outage at 3 o'clock on a Sunday morning, and I haven't touched my own code for 6 months. Okay? I'm probably not going to be thinking all that well. I want the code to be really, really simple and really, really obvious about what it's doing because I'm going to be tired and I'm going to be grumpy. Okay, so get inside the head of whoever is going to come next, even if you think that's a scary place to be. Smart me codes for stupid me. Stupid me thinks that he's smart me. Right? We never think that we're being dumb when we write code. But it's a whole lot easier when we just write a convention test or something that says, don't let me do this. Right? Don't let me do this silly thing. And then when stupid me actually does that silly thing and the tests fail, that's a whole lot easier than having a production outage. Code's a mindset. Well, beautiful code is a mindset. What am I thinking right now? What idea am I trying to express? Not how do we implement this thing, but what am I trying to express? And then what am I going to be thinking when I read this again later? So that's really, really important. Think about, you optimize your code for reading. Don't optimize your code for the compiler. It's better at it than we are. Don't optimize your code for performance. If you really, really, really must have performance, at least profile the thing first. But optimize it for readability, understandability, and then when you have a couple of loops that you really need to wind very tightly, then we're talking, okay, we can make that a little bit more ugly. But optimize for readability. So let's actually look at some code. Oh, wow, and my mouse is really, really quick on this one. Okay, so I'll apologize in advance. We don't actually have much functionality in the app. So you're not going to see Felonious Grew or anything here. I just stole the color scheme. Okay, can everybody read that font? Yeah, all right, cool. So this is a really, really simple app. It has one link that functions, which is one that's just going to point me straight at an API. And for the rest of this, we're going to be looking at a JSON API, and it's really, really boring. We can apply these principles to everything, but Web API is a really simple example, and it supports a whole lot of the stuff that I care about covering today, so that's what we're going to use. So I'm going to grab this and, oops, not that one. I'm going to, oh, hello. We've really moved. For a university, we still have like itty bitty screen res. So yeah, we're going to do this in Chrome because Internet Explorer will pull down JSON and download it and save it to disk. Whereas here, we can just look at download. Okay, so I've gone to my API/v1, and I've asked it for a list of supervillains. And I've gotten back Felonious Grew. Come on, who knows Grew? Who does not know Grew? What is wrong with you people in pop culture? Okay, so I don't care. It's not for you. It's funny. I liked it. I liked it. You're mean. Okay, so we've got Felonious Gru, then we've got Margot, Edith, and Agnes. Okay, if anybody hasn't seen the movie, just go and see the movie. And all we really care about is our API that gets us a list of supervillains. Okay, and I'm going to search for Gru. There we go. And it's done a substring match on all of their names, and we're happy. Okay. So for the bulk of this one, we're just going to have a look at the Web API controller behind this, because it's a really, really common case for where code goes horribly nasty, horribly quickly. So let's have a look at that. So if I go to supervillain 1 controller, make that big. Why are you not pinned? There we are. Okay, actually, first I'm going to make this small, and we're going to fit this whole thing on one page. Still going. There we go. Oh, yep, there we go. Hooray, who can read that? That's kind of the point, right? That's a bit yuck. Now let's have a look at what this controller is actually doing. Incidentally, the reason that we're using attribute-based routing here is so that I can put multiple versions of this API in the same codebase at the same time, and it'll be on GitHub fairly shortly after this talk, so you can actually go and have a sticky peek. Right. This is ugly. Don't do this. So we've got a supervillain controller, API/v1/supervillain, and that's our get. We can get it, or so that gets our collection, which is ick. We've got one which is get by ID, which we can come back to. We've got our search. And then we've got post, which actually allows us to update a supervillain, which we're not going to do. Okay, so pretty much everything that we care about for the majority of this talk is just going to be in the search API, because it's a really simple example. So what's this method do? Let's pretend for a second this method is the only thing that we care about. What are we actually doing in it? So what's the first thing we do?
Validate model.
Right, we check our model state. Is model state valid? Okay, I don't know, what's that mean? What does that mean in the context of a name? What's that going to allow me to pass in? It's going to allow me to pass in anything I want, right? Anything that comes in the pipe, that's fine. We've got no validation, nothing on there. Tell me, who honestly has never forgotten to put that in a controller action method? Who's never ever written an MVC app or a Web API app? Then you're probably the only people in the room who've never forgotten to do that. Okay? Because I promise you, every single person I know who's ever written anything like this forgets to do validation sometimes. Now the next thing is, we're grabbing a bunch of supervillains, so we're using our supervillain repository, we're calling get all, and then where name contains thing, and then we're materializing that into an array. We convert that to a bunch of DTOs, and then we return a request.create response saying, okay, with a collection of DTOs. Okay. So count the concerns here. How many concerns do we have? Well, we've got the obvious ones. We've got our model state validation. We've got fetch our supervillains from the repository. We've got actually query what the matches are. We've got mapping them into DTOs. We've got returning an HTTP response. Okay. And then we've got some like routing and a bunch of other things here, maybe some model binding. So we've got at least 5 concerns in this one method. How many concerns then do we have in this whole controller? That's a little bit horrible, so let's not do that. So let's simplify these things one by one. And here's where I see if I can remember which bits I actually fixed as we go through. Here's that one. Let's have a look at this one. So what's different about this one? What's different about this method? So it's the same search method. If I flick back to our Chrome instance and I change my API version to v2, we get the same output, which is great. What's different? Parameter. What's the parameter now? It's a DTO. Who got the parameter? Was that up there? Fantail incoming? Ow, and I shouldn't turn my head, sorry. Okay, so we've got a parameter. We're actually taking a DTO as a parameter now. Now, why is that useful? Well, because we can then validate that. Right? We can then start putting validation rules on that. We can use our system.data.annotations to validate that kind of stuff. Okay? And we probably should, but right now we're not. The rest of this is the same, and it's all kind of boring. Let's skip supervillain controller. Oops. Supervillain. Where are we? Hang on, I moved that. V3. V3, what we've done is we've actually started to extract this. So if we look at the V2 code, we've got a whole bunch of stuff that just happens to be grouped together because it's all about a supervillain, all right? So we've got 83 lines of code, and if our supervillain can do like more than one thing, then we're going to have thousands of lines of code before you can blink, right? So next version of our API, what if we just adhere to like the single responsibility principle a little bit more and actually try to make a controller that's only really responsible for one action? Does that make sense? Yeah. Now this does a couple of things that aren't immediately apparent. Who's seen the fat controller anti-pattern at play? Who would recognize it if they spot it? 2,000 plus lines. How many constructed, I asked earlier who's not used an IOC container. Everybody's used an IOC container. What happens when you've got a 2,000 line controller? Bingo, incoming. Oh man, I have got to stop turning my head. I'm sorry. Yes. You have a gazillion thingies that you need to pass as dependencies. And so that means that when I create my unit test, I just want to test a 5-line controller action, and I have to create 20 different mocks or substitutes or stubs or whatever just to create an instance of this stupid controller. And so what do I start doing? Well, I start cheating and just passing in nulls, because I'm not null checking anywhere, because I've forgotten that too, because I'm bad. So then I go, hey, var foo controller equals new controller where, new controller null, 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 mock, null, 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 null. Hang on a minute. Was this the null or was this the mock? Oh, I can't. Right. This is not a fun experience, right? This is crap. We don't want to do that. So adhere a bit more to the single responsibility principle. That means we can start to minimize the number of constructor parameters, which in turn makes it a whole lot easier to start stubbing and mocking our actual dependencies. Not only that, but we've only got actual dependencies in here. So we've got a whole lot better an idea of how this thing's actually supposed to work. But that said, I'm still forgetful. I'm still going to forget to do things. I'll probably forget at some point to validate models. You'll notice here as well, we don't even have any validation attributes on there. So, model state is valid. This can still be null. Whoops, well, that's going to end well. So let's not do that. In our v4 of our API, we're still a little bit icky. But now what we've got, and we can change some of this code, now what we've got is a model validation attribute on here. Can everyone see that? Okay. So we've added a model validation attribute. We're taking a search DTO. We're still returning an HTTP response message, which isn't that great. We've got some validation attributes on here, but this method still does way too much. So the last one that we should be looking at, and then we'll fly a little bit solo for a bit. This is a little bit better. Now, this is not yet beautiful by any stretch, but it's starting to illustrate a few things. And there are a few things that aren't going to be apparent here until you realize what some of the conventions are that we've applied. Firstly, where is my validation? Have I forgotten to validate my DTO? Sorry?
I think the global attribute are the executed.
Bingo. Lolly for this man. Lolly for Judgy. Well done, Judgy. Did I teach you that? Money well spent. Okay, so we've started to introduce... Oh man, hang on. I have to complete the bow now, even though I can't. All right, so we've started to introduce the concept of aspect injection. Now this is a really, really simple but powerful concept, and it basically says every time I do this particular thing, I want something else to inject a cross-cutting concern for me. Okay? So I don't want to have to remember to validate my parameters. I just want something in the framework to do that for me. And if there isn't a thing, then I'm going to write a thing. Okay? The second thing is I want to be very clear about what my responsibility is in this controller and what it's not. Notice there's no error handling in here. Why is that? Is that because I'm lazy? That's a trick question, isn't it? Yes, I'm lazy, but I want to be able to be responsibly lazy. Okay? So what I want to be able to do is to say, I don't have to validate any inputs here because something magic is going to do it for me. Likewise, if I throw an error, if I throw an exception, I don't want to have to deal with that because something else responsible should do that for me. Okay? I want to be able to say, I take a search request, which is valid because the framework has given me that validation, and I'm going to return a search response. And likewise, I'm going to promise that that thing is set, because if not, I've got something that will tell me that I've violated my own service contract that I've advertised to other people, and I probably shouldn't let that go out the door. Okay? Slight side note, we might not get to this, we probably won't. Who's seen the mediator pattern before? Anyone? Okay. Anyone not? It's okay, just about half-half. Okay, cool. If we get time, we'll have a look. If not, then have a sticky beak on the code afterwards. Okay. So let's have a look, though, at what we're actually doing here. So the first thing is, my controller now is only really responsible for routing and then dispatching that request. Okay. That's pretty much it. So we've got action filters, which we'll have a look at, which are responsible for all of the things like, if I shrink that for a second, let's go to our infrastructure, action filters. There we are, model validation. So here's where we've outsourced our concern. Now this means that every single HTTP request that comes into my web API gets validated. And if you don't have a valid request DTO, it's a 400 response, bad request, I'm not talking to you. But conveniently, because we're not just returning false and 400, we'll actually give people a collection of reasons why we failed. So we'll explain to you, hey, you didn't give me a name to search for, or you didn't give me an email address, or the email address doesn't look like an email address, or whatever. So we're making it really, really simple for our consumers of our API to understand what they've done wrong. We've made the documentation trivial because it's all done by our attributes in our DTOs. Okay. We add some convention tests. Who's heard of convention tests? Who's not heard of convention tests? Okay, who's heard of reflection? Okay, who's heard of a loop? Well, hey, you know, has anybody not heard of a loop? Ow. Laugh if you will. Where's Marita and her robot arm? I know, I'm sorry. Okay, so if you know the basics of reflection and you can write a for loop, you can write a convention test. Basically, a convention test reflects over your code and says, for each controller, there should be a route attribute. Sorry, for each controller method, for instance. So get me all of those defined types in this assembly, get me all of the methods off all of those types, and then assert that for each of those types, there's a route attribute on it. So we haven't just relied on the convention unless the convention is something that we want to adopt. In this case, I haven't because I wanted to put multiple horrible versions of different things. But likewise, we can assert things like all my method parameters must be DTOs. I don't take primitive types anymore, which means that every single parameter is then going to be a DTO that can have validation attributes on it. Then I can go through and spin through all my DTOs and say, hey, all of my attributes, all of my properties on my DTOs have to have validation attributes on them. Now, as far as writing tests for my code, now that means I can make a whole bunch of very strong assumptions. One, if I have a controller action, its inputs will be validated. I don't have to worry about that. I'm never, ever, ever going to forget that, because I don't have to. The dumb machine will do it for me. Two, testing validation is as simple as newing up the DTO and then saying, hey, is this valid? I know that if I new up the DTO and my validation rules around that are correct, I'm in a happy place. Okay? I'm never ever going to forget, so I can guarantee that what comes in the pipe is actually going to be correct. Likewise, on my outbound, well, what if I've created a DTO that's not valid? I shouldn't be returning that to people. I know it's wrong. Now that's an internal server error. I, the server, have made an error. I am sorry. Here's a 500 and an apology. And I'm going to log it, but I'm not going to return the caller garbage. I know it's wrong, so don't give it back to people. Right? So don't propagate our bugs either. Does that make sense? Who's actually done that in a codebase? Okay. Who would consider doing that in a codebase now? I'm winning. Excellent. Okay, so the next thing that we care about is login. So let's have a quick look at what's actually going on here. So we're running this web app at the moment. Whoops, not that one, this one. And I've just made another API call. And it's really useful. Whoa. Wow, okay. This is how the other half lives. Sponsor. Ah. You're a bad person. Is that you, Adam? Okay. Fantail for Adam. Well spotted. Okay, so we've got structured logging, and that's really, really cool. I'm just going to say, rather than search, I'm going to get by. And I've gotten a 400. Actually, did I get told off? No, because that's actually a caller error. But I've actually logged the fact that I've returned a 400 to someone. It's just a valid, like input's crap. Sorry, never heard of you. Go away. Okay. If my code crashes, I get stack traces in here. I get stack traces in here no matter where I log them from. Okay, so it could be this web server, it could be another one of 50 web servers in a pool, it could be a back-end Windows service, and they all correlate. Okay. Which brings me to correlation. Write down why you started to do a thing. Now, obviously, we're talking about this in the context of Web API, but you want to do it everywhere. Anywhere you've got a distributed system, and face it, it's 2015, everything's distributed. You want to correlate where a thing started and where it ended up and why. If A calls B, B calls C, C calls D, you want to be able to understand at D that you were there because of A. Okay? So, and it's really simple. If you're talking HTTP, just shove something in the header. Okay, if you're passing messages around the place, then you're going to have a property bag of some sort, so stick a GUID in there, job done. Okay? It's not hard. But then what you want to be able to do is actually correlate. I don't think we have a correlation ID in here because I was lazy. We do have a HTTP request ID. No, I've not added that in yet. Okay. But then we can actually say, okay, I want you to show me all of the log messages that resulted from this web service call over here. Customer loads a page. Some web service in the middle of our backend goes kaboom, and I want to see what happened in that whole lead up. So I want to do that. Now, the next thing that we care about, who's read the blue book? Who's not read the blue book? Who's read the blue book and stayed awake? No hands. One hand, kind of. Okay, so if you haven't read Eric Evans, it's well worth it. I'm not going to go too much into DDD here, other than to say that domain-driven design is basically make your code look like the stuff that you're actually going to model. Okay? If we have a supervillain class, so if we have a supervillain, and the supervillain can shrink someone with a shrink ray, or freeze someone with a freeze ray, then we have a method called shrink someone, or freeze someone, or whatever, on a class called supervillain. We make our classes look like the universe that we're modeling. Now, that abstraction will leak, because it's an abstraction, and all abstractions leak, but we at least want to make our best efforts we possibly can. So what that means, though, is that we've got a lot of responsibilities in our code that are cross-cutting that we don't want in our entities. So let's have a look at our supervillain entity. We've got a couple of concessions to our ORM. I'm pretending that we've got entity framework here because why not? But we can't actually create a supervillain without giving them at least an ID and a name. They can do a couple of things. So one, we can sign up as a supervillain. And then the next thing we can do is, forget about this one for now, we can acquire a minion, right? Because supervillains all need minions, right? Yeah. Now, the thing with acquiring a minion, though, is that that's not always going to be okay. So for instance, if Gru's run out of cash, he can't acquire more minions. And I don't know, tell me, somebody, give me, what's a minion name? Dave. Okay, so we've got Dave. All right, says he who mocks me for having a toddler. Okay, so if we've got a minion named Dave, we don't want to get another minion named Dave. Okay, so when we call acquire minion and say, hey, acquire this minion, well, no, this supervillain already owns a minion of that name, so I'm going to say fail. Okay, so I've got a guard method, say guard against, I can't do this with this reason, and it's going to give me a collection of failures. Okay? So my supervillain can acquire a minion or not. It'll have an opinion about whether you can put it into that state. It's not just a dumb property bag. Okay? Our entities have rules. They are responsible for maintaining their own internal consistency. They're responsible for using and implementing our ubiquitous language. Okay? If a supervillain doesn't acquire a minion, if a supervillain gets a minion or subverts a minion or whatever, that's what the method's called. Okay? Call it what it does. Call it what the people who actually talk about this stuff do. Now, this is not the dinosaur talk, but we're going to introduce the concept of domain events really quickly because they're important, because a domain event is a way to say that I don't have to do cross-cutting concerns here. Okay? We've got some rules. Our rules are, when a supervillain signs up, all of the other supervillains should take note. Okay, there's a new supervillain on the block, right? Vector rocks up, and Guru is like, who the hell are you? Where do you come from? Are you really missing that reference? Oh, man. Okay, so when a supervillain signs up, all of the other supervillains should take note. Now, the key there is when we hear the word when, that's a domain event. When we hear the word when, that means that it's not my job to do that thing. So let's have a look at our sign up method. All we're going to do is return a new supervillain out of that. And in here, now, I guess we've come back. We haven't used any argument checking yet because of magic that we'll come to. We're going to set my name to name. We're going to call base with the ID. And we're going to just announce to anybody who cares that a new supervillain has signed up. That's it. Right? This supervillain doesn't have to know about all of the other supervillains. I don't have a supervillain manager class, which is really bad. Okay, I don't have a, I can have a supervillain management service, but it's still a really bad thing because anything with management in its name is kind of like the just third drawer of the kitchen, right? You just chuck random crap in there because you don't know where else to put it. So what's going to happen though? What are the rules? So when a supervillain signs up, all of the other supervillains should take note. Now what we should be able to do, where are we? Is we should be able to figure out what we're supposed to do without even opening code. Let's see, can we see that very well? Magnifier, whoa, there we are. Okay, so we've got our domain event handlers here, and we've actually dropped them into namespaces. So when a supervillain signs up, all the other supervillains should take note. Okay? I don't even have to read this class to know that that's a rule now. Okay? And I can, but let's have a look. Likewise. How do I close magnifier? Go away. There we go. Okay, so let's have a really quick look at that one. When the supervillain signs up, all the other supervillains should take note. We've implemented iHandle event. I'm not going to go into that infrastructure, but it will be in the code. You can have a look. What we're going to do is we're going to grab all of the other supervillains, and then we're going to say, okay, do take note of the new one, done. Okay. Now, you've got, let's say, 10 seconds to mentally parse this. Can you do that? Who reckons they could not mentally parse what this class does in about 10 seconds? Yeah. Well, that's good. I didn't completely fail. So we want to be able to look at this class. Firstly, I want to be able to crack it open and see, is this what I care about? Is this the class that I'm supposed to be adding to or changing? But then secondly, how does it actually achieve what it achieves if I need to understand that much? So without looking at any more code, what are some other rules about our system that we now know? What's the other thing that a supervillain can do? They can sign up. And the only other thing that a supervillain can do at the moment is they can acquire a minion. Yeah? Fair enough? Now we've got this pattern that we should probably call out explicitly. Check your preconditions, do the thing, announce that the thing was done. Okay. You will see that recur a lot. Thanks, man. You'll see that recur a lot. Check your preconditions, do the thing, announce that the thing is done, your job is finished. Anybody else who cares will do their thing because you've made that announcement. Okay? So that's what's called a domain event. Right? I'm announcing that I've done this thing, and anybody else who cares should care. So in this case, let's say Guru goes and recruits another minion. That's wonderful. That gets announced here. Hey, I've acquired another minion. That's great. What happens? When a supervillain acquires a minion, what's the rule? Right, all their existing minions should rejoice. Yes. Hooray, like there's a new, yeah. Okay, so when a minion rejoices though, what happens? Right, another minion should smack it. Okay, hooray, hooray, and then everyone gets a smack. And I did that without even hurting my back. Okay, so we can start seeing these rules of the system without even looking at the code. Now, we could put this in a manager class. So then we have a sign-up manager. And then all of a sudden, a supervillain sign-up manager is responsible for signing up the supervillain, telling all of the existing minions to rejoice, and then telling all of the other minions to smack a random minion. Telling a random minion to smack all of the minions who've been rejoicing, okay? Now, imagine that that's all in one file, and then we want to change something about that rule. Right? Or imagine that we want to add something else. So like when a supervillain recruits a minion, somebody else tries to steal them back. Where does that go? It goes into the same manager class, right? What happens if 5 people want to add 5 different additional behaviors? Merge conflict, right? Why are we all messing in the same file in the first place, right? Why aren't we just in the separate files where we're just adding code? If we're adding behavior, and this comes back to a fairly general principle, if you add behavior, just add code. Right? Preferably, just add a class. Not even a method to an existing class. Sorry? BizTalk. I'm not sure if that's trolling or just swearing. But we want to be a whole lot more additive. Being additive scales a whole lot better. right? Because 5 different people can add 5 different classes all in parallel, and the only thing that's going to be a problem is a CS proj file if you're talking old school Visual Studio. Okay? If you're talking new school Visual Studio, even that problem goes away. Okay? So let's quickly flick back to this one. Here's more code. A couple of general principles. If trip over it, you do. Fix it, you should. If you confuse yourself, or if something confuses you, change it. Okay? Don't just go, oh, that was really dumb. I'll remember to not do that next time. Okay? Oh, I should have null-checked this thing. Or, oh, that's really confusingly named. Right? Change it. If you can't change it, make it easier to change. Right? You don't have to change the world all in one go, but do something to make it better for the person who comes next, because that person who comes next is probably going to be you. Okay? Don't make me parse stuff. Don't make me mentally parse stuff. So remember when we looked at our domain events? Right? We know the rules. We didn't even open those code files. We didn't even open those files, but we know what our rules are. Right? When someone acquires a minion, all the minions shall rejoice. When a minion rejoices, another minion should smack it. Okay? We didn't even open that code. Okay? Likewise, we want to explain what the code is achieving without necessarily making me understand how. I only care about how if I have to change how. Okay? If I care about the what it does, then I just need to know what its name is. And if I care about the why should be implicit in where it lives in the code base and what I'm trying to achieve. I don't want to read the code. We've covered mapping our domain model, so I'll skip that one. We've covered our check, do, and announce pattern, okay? But that's really, really important. If you only take one thing away from this talk, that should be it. Apart from, like, it's nice to be happy. Now, once we've done all of this stuff, we've basically implemented the S in Solid, right? There are a bunch more letters in the acronym. But once we've done that, we've made all of our testability a whole lot easier, right? Our classes are smaller, they do fewer things. Hey, guess what? We can now write better tests. We can test by convention, which we should. We all know about convention tests now, right? It's reflection plus a for loop. Right? Which means if I add a new DTO and I forget to put validation attributes on it, I can have the tests already run and tell me. I don't have to write a test for that DTO anymore. Right? So if I add code, and if I add code in a conventional way, then I don't even have to write tests for a lot of that code because those tests will already pick it up and run. Likewise, it's a whole lot easier to unit test when you only have to mock a few things. Then we want to integration test, and as a last resort and a smoke test, we do our UI automation. Okay? If we're writing all of our acceptance criteria and then putting all of those into browser-based acceptance tests, we're going to have a really, really bad day. Likewise, when we're adding features, remember, just add code. We've covered a little bit of aspect injection. Right? Now, you'll notice in this code base, I've not added a single null check. Why is that? Well done. Bodhi. It's actually not in there yet. It's in a stash locally. Straight behind you if you may. Because I hate checking things for null because I forget. So don't let me forget. Smart me knows that stupid me will forget. Stupid me thinks I'm fine, right? So why not just optimize for that? Sorry? It's the pain meds, yeah. What's the excuse for the rest of it? I mean, no. Okay, so wherever you can, wherever it's sensible, aspect inject all the things. The first time you start whipping open something like PostSharp or Foti or whatever, you're going to cut yourself. You're going to drop it on your foot. Just don't go overboard, but it's important. Okay. One other thing I would add: if you're commenting some code, don't. Comments are either an apology, right? They're like, I'm really sorry that I didn't make this easy enough to understand without commenting, okay? Or they're an explanation for a decision that you made. Your code's actually made a decision, and then you're doing a thing. Why not log that? Right? So rather than just, hang on, I can't take over the world because I've got no minions, so the only thing, if minions null, just return, no, I failed. How about if minions null, whoops. I should totally fix that bug. All right, that's interesting, that text is wrapped. Okay, but I log it, and then I return. Okay, so I've put the comment, I've gone to the trouble of writing the text when no one's ever going to read it unless they actually stick it in, unless they actually open it up in the code. Why don't I just put it in the logs? Okay. So a couple of final thoughts. When we think about what we're optimizing for, think back to short term, we care about agility. Medium term, we care about sustainability. We care about being able to be agile for the long term. We care about being able to do what we do day in, day out without hating our existence, which comes to 3. When we're happy, we can then take a step back and we can think about, you know what, I'm totally bored with building forms over data. I want to do something cool. And I can apply these cool things to an amazing project. Right? I can do something that is going to change the world or change my world, or I can just do a local charity project, or I can write my own app that keeps my shopping list. Whatever makes me happy, I can do that when I actually have a sustainable working environment, a sustainable job. When I'm otherwise sustainable and relatively happy, I can then make a bigger difference to my life and hopefully to other people's. With that, don't forget your feedback. Don't forget you can win stuff. Thanks all. I'm so sorry.